Let's continue working on this set of questions. We are at question number 23 now. Suppose you can earn 1% per month on a dollar invested today. What's the APR and how much are you effectively earning? So in this question, so you make 1% per month. So in a year, so it should be in a year you should be earning interest 1 month per month for 12 times in a year. So for this question, APR should be 12%. Yeah, so it should be 12% APR. Now effective rate should be 12.68% because you're compounding at 1% every month for 12 times in a year. So if you do that mathematically, so you see your interest rate should be 1 plus 1% with the power of 12, subtract 1. So you're increasing at 1% every year. Your account value increase at 1% every year. So for 12 times in a year, so it should be 12.68%. So this is your EAR, effective annual rate. Effective annual rate here. So, or you can use effect function in Excel. The inputs are 12% and 12 in this case. So in this case, if you invest $1 today, and your returns will be 12.68% in a year, or 1%. Your return is 1% in a month, each month, but in a whole year, your return is 12.68%. You see, you can use effect function in Excel to do that. Let's say go to formula, look for financial, look for effect, EFFECT. So nominal interest rate, this is just the nominal rate is just this APR, 12%. Don't put 1%, put 12%. Amper is how many times it's compounded in a year, so put 12 there. So your return is here. So this is the answer. So this is this question. Number 23. 24. Suppose you put it in another account to earn 3% per quarter. What's your APR? Okay, so it's 3% per quarter, 4 quarters in a year. So that's APR is 3% multiplied by 4 equals to 12%. So how much is effective annual rate? Now your APR rate is a nominal rate, is still 12%, but Ampery is not 12 anymore. Ampery should be 4. So your inputs should be effect is the function 12% and 4, so it should be 12.55%. This is your answer. You see, so it's different. Okay, now let's go to 25. You are looking at 2 saving accounts. One pays 5.25% with daily compounding. So 5.25% is the APR, annual percentage rate. Your daily interest rate should be 5.25% divided by 365. That's your daily interest rate. So interest is going to be compounded on the daily basis. It's calculating the interest and add it to your account every day. Okay, so the other one is paying 5.3%. This is APR, but semi-annually. So each semi-annual rate should be 5.3% divided by 2. So which account should you use? One is daily, seems lower. One is semi-annually, seems to be higher. So you cannot compare on the APR basis. You need to compare on the EAR, effective annual rate. And effective annual rate, EAR, tells you how much returns you're getting every year. So you should calculate the EAR rate. Okay, so you see, here's the answer. For daily, you use effect. Input should be 5.25%, and the Ampery should be 365. So you got 5.39%. And that means every year you're getting 5.39% of return. If it's semi-annually, APR or nominal rate is 5.3, but it's compounded twice a year. So Ampere is 2, so you got 5.37%. When you compare these two, of course you should get the daily compounding at APR 5.25%. Okay, you can verify. You can verify, and suppose you invest $100. You can compare if it's daily. This $100 will be how much? $100 will be how much a year later? So you can do this calculation. So it could be it's equaling to this. The rate is 5.25% divided by 365, and 365 is an ampere, and 0 for payment, $100 for present value. Okay, so you can do this, and it should equals to 105.39. Okay, so if it's semi-annual, so it's close, then, but however, it's 5.3% divided by 2, and 2 times in a year, so you will get 7. So if you do this calculation, that should be your answer. Okay, so let's look at question number 26. Suppose you want to earn an effective rate of 12%. So this is EAR is 12%. And how much is the APR? Now, there's another equation, but the function in Excel. It's to get the APR, if you know the EAR, and it's not, APR is not a function. Nominal is a function. So you use nominal, go to formula, financial, nominal is a function. So you see effect annual rate 12%, and ampere is, because this is monthly, right? So 12. So you see, so here 11.3 11.39 is the answer. 11 point, that's right. So you can just use nominal. The first input is effective annual rate, second input is ampere. So that will give you the APR. APR is always smaller than the effective annual rate. To do mathematically, EAR, we know like the equation is this. You can find this equation in the website, class website. A equals to APR divided by N. This is your periodical, the interest rate in each period. And with the power of N, subtract 1. This is EAR, math equation. And from this equation, we can derive the APR equation. So APR equation should be 1 plus EAR with the power 1 over n, subtract 1, multiply by n. Right, so this should be the equation for EAR, for APR. Okay, but you can use nominal function in Excel to do that. Okay, so this is 26. 27. Suppose you want to buy a new computer system and the store is willing to allow you to make monthly payment. The entire computer cost is $3,500. The loan period is for 2 years. Interest rate is 16.9% with monthly compounding. What is your monthly payment? So this is just similar to the other questions we've done earlier. So computer is $3,500. That should be your present value. The ampere should be 2 years, but multiplied by 12. rate should be 16.9% divided by 12. Future value is 0. So compute for PMT. That's the answer. This is just an annuity, owner annuity question. Okay, so this is this one. 28. Suppose you deposit $50 a month into an account that has an APR of 9% based on monthly compounding. How much will you have in the account in 35 years? Okay, so this questions, this is also another annuity due, owner annuity question. So $50 should be your PMT. APR is 9%, but you're making monthly payments, so your interest rate should be 9% over 12. 35 years multiplied by 12, that's the ampere. It's computing for FV here. This is just the same like we've done before using future value function. APR is always like this is the bank's rate. You will be told about this APR rate, but you need to convert it to like actual compounding rate each period. Okay, 29. You need $15,000 in 3 years for a new car. If you can deposit money into an account that pays an APR of 5.5% on daily compounding, how much would you need to deposit now? Okay, so, well, see, APR is 5.5%, so rate should be 5.5% divided by 365 here. So you make one deposit now, so you compute for the present value of this $15,000 and car payment 3 years from now. Now ampere is 3 years, but how many days? So 3 multiplied by 365, that is the ampere here. So this is 29. Question number 30. If a T-bill is treasury bill, promises to repay $10,000 in 12 months and market interest rate is 7%, how much will be the bill sell for in the market? Okay. Let's just assume this is monthly compounding. So 7% divided by 12 would be your monthly interest rate. So ampere would be the whole year, 12 months. So how much you pay for that? The future value should be $10,000. You compute for PV. So so this is the answer. 31 is deleted. Let's do 32. Okay, an investment will pay you with $100 at the end of each year for the next 10 years. And what is the present value of the annuity if the discount rate is 8%? What about if it's the present value of the above payment received at the beginning of each year? This is just similar. You can look at the solutions I put there. The difference between these two are just like one. For the first part, the type is 0 or omitted because this is just ordinary annuity question. For the second one, the type should equal to 1. That's the ordinary annuity questions. So that there's a difference. Okay, the last one in this set of questions, what will be the future value if you open an account with $1,000 today at 8% for 5 years and then make the 100 deposit at the end of each year? Okay. So, you see, so in this question, you open the account and put down $1,000, so that should be your present value. And PMT should be 100 because you deposit $100 at the end of each year. The interest rate should be 8%. Ampere should be 5. And then you compute for future value. So this is this question. That's all for all this week, chapter 5 and chapter 6 exercise. And if you have any questions, please let me know. That's all.